Slide lecture. Additives that give concrete and ceramics special properties. For students of the educational program Production of Building Materials, Products and Structures. Topic: Methods of preparation and application of effective modifiers. Lecturer, Associate Professor, Ph.D. Sarova R.F.
Lecture Plan 1. Hydrophobic additives. 2. Antifreeze additives. Purpose and types. 3. Polymer additive. 4. Biocidal additives. 5. Additives for ceramics. 6. Skinny additives. 7. Fluxing additives, fins. 8. Burnout additives. The purpose of lecture. Study the additives that give concrete and ceramics special properties.
In modern construction, there is a tendency to use materials that provide durability and strength of objects. First of all, this applies to concrete structures, the manufacture of which requires the use of various chemical and mineral additives. Concrete is an artificial stone material obtained as a result of hardening of a concrete mixture consisting of cement, water, aggregates and special additives. Various additives are used to regulate the properties of concrete mix and cement economy. They are divided into two groups. Chemicals added to concrete in a small amount, 0.12% by weight of cement, to change in the desired direction of the properties of the concrete mixture and concrete. Thin ground materials added to concrete in an amount of 5–20% or more to save cement or to obtain dense concrete at low cement costs. To fine ground additives include ash, ground slag, sand, waste stone crushing and some other materials that give concrete special properties, increasing its density, heat resistance, coloring, etc. Hydrophobic additives. Hydrophobic additives are substances that give the walls of pores and capillaries in concrete hydrophobic, water-repellent properties. Hydrophobic additives, which include many organic substances with a sharp asymmetry in the structure of their molecules, are introduced into concrete and mortar mixtures in order to reducing wetting of the walls of pores and capillaries, as well as the surface of the products. Air extraction or gas formation accompanied by hydrophysation of the formed gas cavities. Increasing the connectivity and mobility of the concrete mixture, which occurs due to evenly distributed air or gas bubbles in it. Giving concrete and mortars water-repellent properties using waterproofing additives are most effective in thin-walled structural elements of floors, wall tanks, troughs, and, if necessary, to exclude the possibility of interaction of the fluids with the cement. And at high hygienic requirements, flooring, tanks and other surfaces, the moisture which is undesirable for technical or hygienic reasons. The mechanism of action of hydrophobic additives is that they are in contact with the products of hydration of cement deposited in the form of tiny droplets on the walls of small pores and capillaries, forming a hydrophobic coating. As a result, there is a contact having an inverse angle at which the surface tension forces push water out of the pores. Antifreeze additives. Purpose and types. Hardening of concretes and mortars at low temperature is slow, as the process of hydration of cement slows down. Already at a temperature of -3, -6 C, water in concrete freezes, and the processes of hydration of the binder and hardening of concrete almost stop. When thawing, subject to preservation of the liquid phase, these processes are resumed, and the concrete continues to increase its strength. However, for concrete frozen at an early age, after thawing and subsequent aging, loose structure, low strength and frost resistance are characteristic. This is due to the fact that freshly laid concrete contains a lot of water, which expands when frozen, loosens the cement stone and breaks the adhesion of the aggregate to the cement matrix. Of concrete in the winter, it is necessary to create such conditions under which the processes of hardening of the binder will actively proceed. It is necessary to ensure the presence of the liquid phase. This problem can be solved, for example, by maintaining the concreted structure at a positive temperature. Such aging can be carried out when heating concrete in thermoactive formwork, using heated mixtures, followed by covering the surface of the structure with thermal insulation materials and other methods. In those cases, when on the construction site for technical or organizational reasons, such methods cannot be implemented, it is advisable to introduce antifreeze additives into the concrete substances that lower the freezing point of water and contribute to the hardening of concrete at negative temperatures. The use of concretes with antifreeze additives is carried out in the construction of monolithic concrete and reinforced concrete structures. Monolithic parts of prefabricated structures. The monolithic knee joints of prefabricated structures. In the manufacture of prefabricated concrete and reinforced concrete products and structures in the landfill at a steady average daily temperature of the outside air and soil is not lower than 5 C and the minimum daily temperature below 0 C. Polymer additive. Polymer materials in concrete are used as additives in concrete or mortar mixture, as an additional binder component, for impregnation of concrete and reinforced concrete products, for the production of dry building mixes, for dispersed reinforcement with polymer fibers, as a microfiller. The main mechanism of action of polymer additives in cement systems is that they form a thin film on the surface of cement grains, aggregate, as well as pores and capillaries, which has good adhesion and promotes bonding, increases adhesion of the aggregate with cement stone. Due to this, concrete becomes more monolithic, its impermeability and frost resistance, tensile strength and bending increase. The most common polymer additives in cement concretes and mortars are water-soluble resins, latexes and polyvinyl acetate. Redispersible copolymer powders are widely used as polymer synthetic additives for dry building mixtures on cement binder. Polymer water retaining additives, thickeners, cellulose esters are successfully used in compositions of dry building mixes. Biocidal additives. To prevent the emergence and development of bacteria, various forms of fungi and microorganisms in the buildings of medical institutions and food factories, livestock complexes, reinforced concrete structures must have biocidal properties. Microorganisms in the process of their activity secrete organic acids, which form with the components of silicates and aluminosilicates complex compounds and easily soluble calcium salts. Mold fungi, accumulating on contaminated surfaces of building structures, also secrete organic acids, citric, oxalic, which are strong cation complexing agents and can form easily soluble complex compounds with minerals. In building structures of increased porosity and hydrophilicity, bacteria settle, contributing to the leaching of calcium ions from cement stone. At the same time, the pH value decreases, which leads to an increase in the degree of carbonization of concrete and its destruction. Bacteria can actively destroy not only concrete, but also steel reinforcement, either directly affecting the steel, or forming in aerobic conditions first nitrogenous, and then nitric acid. To increase resistance against biochemical corrosion, special additives are introduced into the composition of concrete or mortar at the stage of their preparation: bactericidal, from bacteria; fungicidal, from fungi; algicidal, from algae. According to the aggregate state of biocides as solid, powders, liquid and gaseous, fumigants, volatile fungicides and others, on the grounds of solubility water-soluble, slightly soluble and soluble in organic solvents. Biocidal additives are selected depending on the type of concrete or mortar, types of pathogenic microorganisms that can settle inside or on the surface of reinforced concrete structures. Biocides should have a high activity. do not have a negative impact on the environment and do not degrade the technological and physical and mechanical properties of concrete.
Additives for ceramics. Ceramic is artificial stone materials and products produced by firing at high temperatures from clay raw materials. Clay minerals are the main raw materials of ceramic materials, including such as porcelain tiles or floor tiles. They represent the sedimentary and reservoir rocks, consisting of hydrous aluminum silicates with different compositions. Clay raw materials for ceramic materials should have plasticity, fire resistance, binding ability, sinterability. Today, one of the most durable materials is porcelain, ceramic granite.
Various additives are used to impart new qualities to ceramic materials. Such additives as quartz, slag, ash help to achieve high plasticity of ceramic products. When quartz and granite chips are added, porcelain stoneware is obtained. To improve the quality of thermal conductivity, rock-forming additives are used: sawdust, peat, coal waste. Plasticizing additives are used for low-plastic ceramic products. To reduce the sintering temperature of clay, it is customary to use cullet, perlite, slag. To obtain ceramic products with certain properties, various additives are introduced into the clay. Skinny additives. Skinny additives are materials that reduce the plasticity and shrinkage of clays in drying and firing. These include quartz, comote, ash, slag, etc. One. Quartz materials are the most common natural skinny additives. These include vein quartz, quartz sands and flint. They are composed of silica and are thinners due to their ability not to shrink during drying and firing. Quartz and its crystalline varieties are resistant to acids, except hydrofluoric, and less resistant to alkalis. The degree of influence of alkalis on quartz is the higher, the finer its grains are. Two. Dusty quartz, marshallite, is a natural substance from grayish-white to pure white, with high dispersion. It is not pure silica, as it contains a significant amount of alkaline oxides. Marshallite is used in the production of fine ceramics. 3. Flint is a crystalline variety of silica and occurs in nature in the form of pieces of various shapes. After preliminary firing, the best grades of flint without iron impurities are used in the production of fine ceramics. Flint pebbles are used as grinding media in ball mills for grinding ceramic masses and glazes. Four. Comote is made by firing refractory or refractory clays at temperatures of 1000. 1400 C. It is used as a thinner of ceramic masses, in the production of facing tiles, porcelain and faience, fireclay refractories. Comote, unlike other thinners, does not reduce the refractoriness of the masses. The grain composition and amount of comote are determined by the formulation of the Massachusetts for different types of products. It is better to use it fine-grained and when grinding together with clay minerals for uniform distribution in the Massachusetts. Dehydrated clay is used for lack of thinners. It is obtained by heating ordinary clay to 600. 700 C, when it loses plasticity when removing chemically bound water. It is used more often in the production of rough construction ceramics. This allows you to reduce the drying time without the appearance of cracks on the products, to expand the base of thinners. Six. Limestone is a thinning and loosening additive. When heated to 910 C, carbonates decompose into Co and Ki. So you cannot use limestone larger than 0.6 frame to prevent cracking of ceramics. It should be applied fine-grained and in small quantities. From calcium carbonates, chalk is usually introduced into the composition of ceramic masses, since it consists of finer particles, is easier to grind and cheaper than marble. Fluxing additives, fins. Fluxing materials, marshes, are materials that interact in the kiln with the clay minerals to the formation of a more fusible compounds. Therefore, the introduction of fins into the Massachusetts improves the degree of sintering and reduces the firing temperature. Smelters are divided into two groups: fluxing, having a low melting point feldspar, pegmatites, Seanites, and materials with a high melting point, but giving when firing fusible compounds with Massachusetts components chalk, dolomite, talc. One. Feldspars are melts widely used in the production of fine ceramics. There are the following types of feldspar. Potassium feldspar, orthoclase, KO. Its color is from white, gray, yellowish to brown, and dark red depending on impurities. Sodium feldspar, albite, is NaOlCO. The color is white, often light shades, but also occurs in red, yellow, gray and other tones. Calcareous feldspar, anorthite, KALCO. Plagioclases are feldspars containing a mixture of albite and anorthite in different ratios. Usually white in color. Density of 2.62 to 2.76 G/Cs. The pegmatite is feldspar, the grown crystals of quartz, the content of which may vary within wide limits. Two. Nepheline seanites are accretions of the mineral nepheline, sodium aluminosilicate, with feldspar. The melting point of nepheline is about 1200 C. The alkali content is up to 20%. Nepheline cinates are used by the ceramic industry as substitutes for feldspar in the production of products that do not require the whiteness of the shard, floor tiles, acid-resistant products. Free. Dolomite is a double salt of Caco**-MSO. Varieties of dolomite are used as a substitute for chalk and marble in the production of fine ceramics. The dissociation temperature of dolomite is 765–895 C. It has a stronger fluxing effect on ceramic masses than pure Caco and MCO, which allows reducing the firing temperature of masses and glazes. Talc 4Sin-3 MDO HO has a fire resistance of C. A dense variety of talc is called Juravik or steatite. Its deposits are available in the Urals. It is a soft mineral, easy to process. It is most often used in fine ceramics, including special purpose products. Burnout additives. Burnout additives, sawdust, coal powder, peat dust, coke fines, TFP ash, etc., are introduced to produce products with a lower average density and increased porosity. Sawdust improves the molding properties of the clay Massachusetts, but reduces the strength of products and increases water absorption. However, due to the long fibers, they reinforce the clay Massachusetts and increase the tear resistance and crack resistance in drying. Control questions. 1. What are the additives that give concrete and ceramic special properties? 2. Where are polymer material additives used? 3. What are skinny additives and what do they include?